Okay, welcome back to McNab Chemistry. Today we're going to have a look at oxidation states. Oxidation states. Okay, but before we do this, I just want to revisit atomic structure and just look how atoms of elements are represented on the periodic table. So if we take something like oxygen, you'll see 1680, which means it's got 8 protons and 8 electrons. Okay, that means it's got 8 positive charges and 8 negative charges. Okay, so the overall charge on an atom of oxygen is 0. Okay. So number 2. The question is, what is oxidation state? What is an oxidation state? Okay, so an oxidation state or oxidation states of species reflect the imbalance between the number of protons and electrons in that species. Okay, number 3, I keep using this term species, so when I'm talking about species, what am I actually talking about? So species, or the term species, refers to atoms, molecules, or ions. Okay, so if I take something like oxygen, O2, that would be oxygen molecules, because I've got atoms of non-metals which are covalently bonded. Okay, if I had H2O, that would be a compound, but it'd still be a molecule. Okay, if I take something like NaCl, that's made from sodium ions and chloride ions. So the species that's made up from is the Na plus ion and the Cl minus ion. Okay, first of all then, let's consider the oxidation states of elements. So number 4, oxidation states of elements. Okay, so atoms of sodium, Na, equals the oxidation state is 0. O2, diatomic oxygen, oxidation state of 0. N2, oxidation state of 0. P4, oxidation state of 0. S8, oxidation state of 0. And the reason all of these have oxidation states of zeros, or 0 even, is that the number of protons they have equals the number of electrons. So even if I take an oxygen molecule, the total number of protons and electrons in that molecule is the same. Okay, so therefore there's no overall charge. Okay, so that's that. Okay, number 5, let's have a look at the oxidation state of ions. So number 5, the oxidation state of ions. Okay, so let's think about why an ion forms. So if I take something like sodium, Na atoms, that's in group 1, so that means it's got 1 electron in its outer shell. When it reacts, it loses that 1 electron to gain noble gas configuration, so Na minus an electron becomes Na plus. Okay, the oxidation state of the sodium ion is now +1 because it's got one more proton than electron. If I take something like diatomic chlorine, Cl2 becomes 2Cl minus when it reacts. Okay, the 2 there is just the balancing of the chlorine, so my mole ratios are correct and they add up, it balances. Okay, but to go now I need to balance my charges there, so Cl2 plus 2 electrons forms 2Cl minus. Okay, the oxidation state of the chlorine in the Cl2 is 0. Okay, because there's no imbalance between protons and electrons in that. Okay, but then it gained 2 electrons. Okay, this side gained 2 electrons, but each chlorine atom gained 1 electron. Okay, to form 2 times the Cl minus. That's how you have to read that, 2 times the Cl minus. Okay, to form the Cl minus ion there. Okay, so the oxidation state of the chloride ion, so Cl minus oxidation state equals -1. Okay, because each chlorine atom has 1 more electron than proton. Okay, number 6 then. Let's have a look at oxidation states of species in a compound. Okay, so really, if you know your ions, then this is pretty straightforward. Okay, so if I take something like the sodium chloride compound, it's got a nice lattice structure made of sodium ions and chloride ions. Okay, so we know that's made up of Na plus and Cl minus. The oxidation state of Na plus is +1. The oxidation state of Cl minus is -1. I have 1 Na plus, 1 Cl minus, +1 -1. Okay, the overall charge on the NaCl equals 0, and it has no overall charge. If you look at that, there's no overall charge on that at all. Okay, number 7. Let's have a look at oxidation states of elements in molecular compounds. So oxidation states of elements in molecular compounds. Okay, so if I take something like H2O, okay, right, let's consider the oxygen. Okay, so if you look at the periodic table, oxygen is represented like this, 16,8,0. That tells me that it's got 8 protons, it's got 8 electrons. Those electrons are arranged 2, 6, so it's got 6 electrons in its outer shell. And the reason oxygen atoms like to react with things is because they'd like a full 8 electrons in their outer shell. Well, if we look at this and we look at our dot and cross diagram for water, okay, I take my oxygen. Oxygen's got 6 electrons in its outer shell, 1, 2, 3, 4, 5, 6. Okay, then covalently bonds with 2 hydrogens, covalently bonds with 2 hydrogens. Okay, the oxygen now in that molecule, it still has 8 protons, but now because it's got these extra 2 electrons in its outer shell, it's got 10 electrons. Okay, so the oxidation state of the oxygen in the water is -2 because it's got 2 more negative charges. Sorry, the oxidation state is -2 because it's got 2 more negative charges than positive charge. Okay. Right, number 8. Let's do a bit of a summary. Number 8, a little bit of a summary of oxidation states. Now I've got this little table here that I'm going to bring into the picture. Oh, look at that. Magic. Let's make that look a little bit better if we can. Okay, let's change that slightly. Yeah, there we go. There we go, a bit of a summary. You can see that elements that are not combined with others have an oxidation state of 0. Oxygen in compounds, except peroxides, have an oxidation state of -2. Hydrogen in compounds, except in metal hydrides, we'll come to that later, have an oxidation state of +1. Hydrogen in metal hydrides is -1. Group 1 metals in compounds is +1. Okay, so that's the group 1 metals, Na+, K+, etc. Group 2 metals in compounds has got an oxidation state of +2, so Ca2+. Okay, right, we'll move that, so that's fairly okay, I think. Now let's have a look at this. Oh, that looks pretty complicated, but you know what? It's just not. Okay, right, so what we need to know is the oxidation state of the sulfur in SO42-. So I've got SO42-. Okay, right, so I'm going to put that on one side. Okay, SO42-. This is how I look at that. I know that each oxygen contributes -2, okay, to that overall complex ion. It's a complex ion because it's got atoms of different elements in the ion. Okay, so 4 times -2 is -8, brings me down to there, but the overall charge on that complex ion is -2. Okay, so what's the difference there? Something has caused the charge to go from -8 of the oxygen up to -2, so something must have contributed +6. Well, there's only one other species there, that's the sulfur, so that the oxidation state of the sulfur in SO42- is +6. Okay, let's do some more. Okay, here we go. Right, she's getting onto it now. NO3-, the oxidation state, well, the charge on that is -1. The charge on the whole species there is -1, isn't it? Okay, so 3 times -2 is -6. I need to get up to +1. Sorry, I need to get up to -1. So that is +5. The oxidation state of the nitrogen in there is +5. Okay, what about this next one? ClO3-. 3 times -2. 3 times -2 is -6. Okay, I want to get up to -1 because the charge on it is -1. Okay, so -6 up to -1 is +5. So the oxidation state of the Cl in the ClO3 1- is +5. Okay, let's have another look at one more. Okay, ClO-. Okay, so the overall charge on the species is -1, so I need to get to -1. Okay, the oxygen contributes -2. Okay, so if I want to go from -2 to -1, remember that's the overall charge on the ion, -2 to -1, then it's +1. Okay, that is oxidation state. Okay, let's just relate that finally then to an equation. Okay, so point number 9. Let's have a look at our equation that we looked at yesterday. Mg plus O2 goes to 2MgO. Balance that up. Okay. I hope you've noticed that the balancing of the equation doesn't actually affect the oxidation states. It's got nothing to do with it. Okay, so I've got magnesium. That's made from lots of magnesium atoms. So the oxidation state of the magnesium is 0. And it goes and it forms the magnesium oxide ionic compound. So that's made of ions. Okay, and in that compound, the species of magnesium is Mg2+. So I'll put that there, Mg2+. Okay, plus 2 electrons on that side there. Okay, so the oxidation state of the magnesium goes from 0 to +2. Okay, let's have a look at the oxygen. O2. Diatomic oxygen molecules become oxide ions, O2-. So 2 of those, plus 4 electrons there. Okay, that's oxygen molecules. So is the element oxygen, oxidation state is 0. Okay, forms the oxide ion. Oxidation state is -2. Okay, and that's just how it works. Okay, that's oxidation state. In the next video we'll be having a look at writing half equations, but for today that's it. So thank you for watching, and we will catch up with you on another day.